4.1, number 15, we're trying to find extreme values using analytic methods. So we start by finding the derivative. F prime of x equals, derivative sign is cosine. So cosine of x plus pi over 4 times the derivative of the inside, which is just 1. So now we can set it equal to 0. So the cosine of x plus pi over 4 equals 0. Alright, so if it was just cosine x equals 0, where is cosine equal to 0? Well, on the unit circle, cosine is 0 on the top and the bottom, because that ordered pair is 0, 1, that's 0, -1, and cosine represents the x value on the unit circle. So if it was cosine x equals 0, x would then be pi over 2 and 3 pi over 2 for our first revolution. But it's not just x, it is x plus pi over 4. So we have x plus pi over 4 equals pi over 2, and x plus pi over 4 equals 3 pi over 2. So we have two solutions to solve here. You can subtract pi over 4, so 2 pi over 4 minus 1 pi over 4 gives you a pi over 4. So that tells me that the derivative is 0 at that point, so we have a horizontal tangent at x equals pi over 4. Subtract pi over 4, subtract pi over 4, 6 pi over 4 minus 1 pi over 4 is 5 pi over 4, and we still have, we're still within our interval from 7 to 7 pi over 4. There may be more. So what we need to do is find the next time that cosine is 0. So going around the circle, 3 pi over 2, all the way to here, which is 5 pi over 2. So x plus pi over 4 equals 5 pi over 2. That's the next time cosine is 0. Subtract pi over 4. So 10 pi over 4 minus 1 pi over 4 is 9 pi over 4. So that is a solution to this equation, but we don't care about it because it's beyond our interval from 0 to 7 pi over 4. So we're done. These are the only two horizontal tangents between 0 and 7 pi over 4. So then we have to check our endpoints at x equals 0 and x equals 7 pi over 4. So our extrema will be found in these four x values. Alright, so now you can graph the original, and I changed the window, made it look pretty. So we've got local min right there, we've got an absolute max here, we've got an absolute min down here, and we have a local max right there. Okay, so starting at 0, I've got a local min. If I plug 0 in to our original, we have the sine of pi over 4, which is square root of 2 over 2. Okay, so that right there is square root of 2 over 2. So we have local min equal to square root of 2 over 2 at x equals 0. There's our first extrema. So the next time is right there. That's a horizontal tangent. That's our pi over 4. Okay, so pi over 4, if I plug it into my original, sine of pi over 2 now, well, that's 1. So we have an absolute max equal to 1 at x equals pi over 4. Right here is 5 pi over 4. If I plug 5 pi over 4 into the original, the sine of 5 pi over, so 6 pi over 4, which is 3 pi over 2. The sine of 3 pi over 2 is -1. So we have an absolute minimum of -1 at x equals 5 pi over 4. And then the last one, the endpoint occurs at 7 pi over 4. That's a local max. If I plug 7 pi over 4 in here, I get 8 pi over 4, sine of 8 pi over 4. Well, that's just 2 pi, so sine of 2 pi is 0. So local max equal to 0 at x equals 7 pi over 4. So those are all of our extreme values, or extrema. We could have known that the maximum and the minimum, the absolute max and minimum, are 1 and -1, because if you think of the graph of the sine wave, the amplitude is just 1 out front, so it's not going, it's just going to peak at 1 and bottom out at -1.